We already saw the requirements. If you want to follow me, if you don't want, it's okay. If you want, install this, please. So what's the plan for the workshop? We will build a simple service in Rust. It's say here that it's effectful service. What it means is that you will be able to call network. Where to get this text? Here. Great. So then we will configure that service. We will deploy it. We will connect it with a front-end application. We will use CLI to the FLDist here to inspect that service and run scripts from CLI. You can run scripts from front-end, you can run scripts from CLI, or you can use your own environment that you like. Then we will extend that service to be able to write data to disk. And I will also explain how to link several modules together. And finally, we will go to advanced part if we have time, hopefully. And we will talk about authorization that's done through tetraplets. We have this term. I'll talk about it. So let's go to our first little example. Here we imagine we want to implement the DuckDuckGo command that I was mentioning in the chat API part. So what I want to have is a separate service so others can reuse it. And I want to be able to call network, to call DuckDuckGo from that service. But there's a problem with WASM and WASM. They do not provide network socket API yet. But how to work around that? We can reuse existing software. I like reusing stuff, and here we will reuse curl. Not as a library, but as a binary that's already running, that exists on the node. So if you want to do that, to call DuckDuckGo in the CLI, you can just do that command, to copy it and paste to your terminal, and you will have some answer that condensed milk is a cow's milk, blah, blah, blah. We will do almost the same, but we will have it as a WebAssembly service that's calling the external binary curl and return the result for us to use in other services. This is a basic building block that you can use to call any external network API, any WebSocket or whatever. And if you ever need to have not a curl, but some other binary, you can run your own node and put any binary there, and you will be able to call that binary from your node. So how to do that? And what API I want to have? I want to have a simple request function that will be callable from air script. It will take a single argument URL and return a string result, either success or error. And the whole implementation of that request endpoint, that request function, is here, is in a single line. It calls external binary curl like a simple Rust, like an ordinary Rust function. It passes a single argument that's an array of a single argument of a single element as an argument to the curl. So it basically does this. You can also keep these parameters, but then instead of having just this, you will do it like this. It's a simple Rust, nothing specific to Fluence. The only specific thing is that we allow to call external binaries as simple Rust functions. So we can have as many arguments as you wish. Okay. But how Fluence knows where this binary is? We surely shouldn't trust or use path variable. So we specify the path to the curl binary in the module config. So that means that there are module configs. You didn't know about that, I presume. So every module, every WAS module has to have a configuration file. If it doesn't need access to file system or the network, it will be just a single field name, nothing else. But here we need an access to external binary curl. And that's why we have to have these field mounted binaries that says that mounted binary curl is expected to be on this path on the node. So let's go to the project actually and review the structure of the project. Here we have several things. First, we have backend folder that contains Rust project. We have a frontend folder that contains a React project. We have a script to deploy the backends. We have a air script to call those backends. And we have this configuration file that allows you to try the service locally. I will talk about it. So let's first review the backend. Right. As I said, it's a simple Rust project that has a single dependency. It's Fluence. It's Fluence Rust SDK. And here, and when you compile that project, you, in result, will have a WebAssembly file. So you will have something like curl template.wasm somewhere in the target directory. We'll do that. We will see. So here, what are the sources of the project? They are pretty simple, as was presented on the pictures. Here I pass two arguments, the URL and the options to make it less verbose. Curl by default is pretty verbose, so that will make it quiet but still show errors. And we have this block that says that we have a mounted binary that's available to be called as a Rust function. So anytime you want to call some mounted binary, some external binary, you will have to do it that way. You will have to have external C around it, so it's so Rust knows it's an FFI, frame function interface. You will have to have this link that points was membered module to host. So runtime knows that you mean running those functions on the host. And you will need to have this macro FC that converts all this and converts underlying types. So you can't have just string in WebAssembly, you can't have just result in WebAssembly. You need to manage pointers and raw memory for this to work. So that what that small three-lettered macro does inside it. A lot of complex logic that you don't have to worry about. You just have to have this macro here. And to describe your public API, you define a function and mark it with FC macro 2. So it converts, it makes it public, it makes it available for scripts to call, and it converts complex structures to WebAssembly format. Okay. So how is it deployed? How to deploy a service to the Fluence? It's pretty simple. The first thing is this, and the second thing is this. Everything else is just a fancy scripting stuff that we don't really care about. So to compile the WebAssembly file, you have to go to the backend folder and run fc build -- release. That's why you need fc installed. So I'm in curl template. I go to backend. I put fc build release, and I have my WebAssembly. I guess it's too small. And I have my WebAssembly file there. Okay. So you can, instead of doing that manually, you can use deploy sh script. You can run it. It will build, and then it will. Oh, that's two. Okay, and it will deploy a service. And once the service is deployed, you will have service ID as a result. So we deploy the service. Let's try to call it. And here, yeah, and surely, where the WASM file, it's in the target folder, so we can check it. It's there. And then this script, the deploy sh script, it uses FLDist tool to create a service. So you basically specify a list of modules as a pairs of WASM semicolon configuration file. And here configuration file we already seen here on the image. It's it. You have a link here to follow if you want. So that already happened. Let's try to call our service. But before that, let's review. Yeah, here is a smaller, smaller version of that script that shows only the main parts. Let's call that service. But first, let's review the script. So to call the service, you use FLDist run air command, and you specify a path to air script, and you specify value for variables that are used inside that script. What it means, variables inside script. So let's take a look at the request air file. Here we have a simple script that goes to a service, goes to a node, which ID is resolved through variable named service. That's why we have here, I will switch tab. That's why we have here this variable that holds a service ID. So yeah, it holds a service ID here. So we can use it. We go to the node relay. Here it's also variable, but run air already gives you that variable to use, so you don't have to specify it all the time. If you switch to another relay, it will be automatically changed. So here we go to relay, where we deployed our service. We call the service by the ID specified as a variable. We call the function request as was specified in the Rust code. We pass this request there, the URL of DuckDuckGo that search for Hamatopy. What Hamatopy means, it's mathematical object and stuff, we will see. And we have the result of the curl execution of the call of the curl binary put into, well, variable named result. And finally, we go to the init peer ID, which is the client's address, and we run this thing. This is specific to run air command. So when we do FLDist run air, we have two variables available for us. First one is a relay, and the second one is return service. That way, you can always return a result to the client by calling this service return service and function run. It will be just displayed in the console. Let's see how it works in action. So here you can see that it's a different service ID. than from what I created, because it was, let me make it a little smaller, it's too big, I think. Hope it's okay now. So we take the service ID we just deployed, we put it here, hopefully it works, yeah, and we get the result. We have the following structure as a result. We have a structure with field error, or a return code, std_error, and std_out. Since curl didn't fail, we have an std_out output, and it's a JSON as was returned by DuckDuckGo API. So yeah, now we know that homotopy, it's a term from topology, a branch of mathematics, blah, blah, blah. Okay, so it works. This second argument, so you have here two things displayed. First one is the result of the curl. Second one is the tetraplet that says where this result came from. That's how security works. I will talk about it, I will elaborate on it later, but in short, you have this thing that's called tetraplet. Why tetraplet? Because there are 4 meaningful fields. There are 4 fields. From what node this data came, from what service, from what function, and from what JSON path, and which JSON path was used to transform the data. So you know that the data wasn't forged in any way. Okay. Oops. So any questions so far? Let me check. No? So yeah, here's an image of the script. We can also use FLDist get interface to take a look at the service. Let me copy it. Okay, service ID is this. And we will have a JSON structure that describes that this service has the following functions. It's a single function called request with a single argument URL of type string. It outputs string result structure, and that structure, string result, it's defined here in record types. So we know that it has those fields, red code, error, std_out, and std_error, all of them strings, except the return code, which is an integer. And it will also show us who is the owner or who created that service. That's the peer ID that was automatically generated. Here, let me show it. Yeah. Yes. Yeah. Was it? Yeah. Client peer ID. That's the one that was used to create the service, and it's the same. So every service knows who created it, and it can be checked in the service function. That's another primitive you can use for authorization. I saw there was a question, right? So yeah, it's recorded, but I will elaborate anyway. I will hope to make it clear that backend is WASM. It's not like a backend is connected to WASM. We have this code here. It says, this is our backend. This is the backend code, right? And this is the API of the backend. This code, it was compiled to WebAssembly module and deployed to Node. So it was a really simple deployment process, and you can have it programmed in different complex way. You can deploy different services to different nodes, different backends to different nodes in a dynamic way, however you choose to do. But here it was simple that we have this code. This is whole code of our backend, no more. We compiled it to WebAssembly module, deployed it, and then called this function, which in its order called the external binary curl and returned the string result structure, which has 4 fields. Okay, hope I made it clear now. So it's really kind of annoying to deploy all the time and waste resources. If you don't want to deploy your service all the time, you can use FC REPL to develop it and test it locally. Here's how it works. You just put, so I was a little ahead of, let me explain. So here we have a simple toml config that describes for FC REPL how to run that service locally. Here we have a specification for a module. It's almost the same as you have seen in JSON, right? It's almost the same as a configuration for this module. Just this is in JSON and this is in toml. It specifies where to look for the module. It specifies the name of the module. Yeah, so we had our module at this folder, right? Under this name .rasm. That's exactly what it says. And here we specify the same mounted binaries. So we tell that the FC REPL should look for the curl on my system. Now it is running locally under this path. So let's run it. To run the FC REPL, you have to specify path to the configuration file. You run it. App service is created immediately, and you can call it. Let's see how we can call it. So it's really simple. You just basically it's almost the same as in the air script. You call the different thing is that you specify here not the service but the module name, and you specify function name and the argument. Let's do that. Yep. And here we have the same output. Well, not the same. In this time, it's about condensed milk, not hamataki. But still, we have the output. We have this object that contains the fields that were the same in the previous call, and we have the result from DuckDuckGo forwarded here to my console. Okay, so it works. Nice. That's how you can experiment with your services locally. And you can have in this configuration file, you can have different modules, I mean, several modules, different modules linked together, and we'll see in a moment how to do that. Okay, so, but first let's take a look at how to connect the front-end application to the curl backend. Let's go to go and see if it works. I'm going to the front-end directory. I already done npm install, but let's do that again. Maybe I shouldn't have, because it takes time. And I don't have much of it. Too bad. Anyway, let's review package.json for now while it installs. So package.json, I hope you know that it allows you to specify dependencies for your project. Here there are two main dependencies for using Fluence. First one is Fluence JS SDK. Second one is a library that allows you to switch between different environments of the Fluence network. Okay, it's done. Let's start it. Hope it works. Would you like another? Yes. Oh, I guess I already have it. Anyway, I already have it running somewhere. So here we have a really simple web application that has the field to enter the URL and the button to issue a request, to issue a call function to the service. We will go through the source of the front-end application in a moment. Here you can see that we sent a request to DuckDuckGo and received the same response. So if I put here another string, we will have Apple disambiguation, definition, text, Apple daily. Well, it's not that good as for homotopy, but still it's we have called DuckDuckGo and received the response. It's a really simple application, as you can see. There's no UX there. So how that application works anyway? It has three main files that I care about for right now. The first one is package.json that specifies the dependencies on Fluence.js SDK, but that we already looked through. The second one is Fluence.ts. It's a TypeScript file. All it does, it gives you a single function to call. It's called call request. It accepts Fluence client as a connection to the node, URL to call, and TTL, meaning that if this request hasn't been executed in this number of seconds, then it should fail. And here we have the script. It's really easy, almost the same as we used with run air, but since we don't have relay variable provided here by default, we have to provide it our own. So it does almost the same. We go to the relay, we go to the node that hosts service. It's the same thing in our case, but still you can have it different. You can have work with different nodes through same relay. And we call service, we call the function request there, we put URL, we get result, and we finally send a result back to ourselves. Right. Here we could use init peer ID in person science, but we decided not to for no apparent reason. It's just a matter of taste. How you like it, you can write it. And here you can see that result is returned to the client through relay. So it's expressed in this way. It says that sequentially go to relay, do nothing there, op identity just nothing, does just nothing. And after relay, go to client and call callback function, callback service with callback function. And callback is defined here. It's done to disambiguate with, so you can see that callback ID is generated on each request. That way you can differentiate between different responses to different requests. It's all up to you how to do that. You can express any business logic or any logic of any application with that. So what we have in result is a curl function that returns some result here by sending the script with that data to the network. Script and data, they are wrapped in a structure called particle. Particle is a network packet that contains, well, script and data and the timeout. And once, and network will start executing the script line by line. And once it goes to that line, the particle will be sent from the relay to the local client and will be executed in a local WebAssembly runtime. So this front-end application, this one, internally it runs WebAssembly module to interpret that script. And once it receives the script, it sees that all those instructions are already executed, and this instruction belongs to the local client. So it calls the callback. And the last meaningful file that glues this all together, it's a simple React application. I'm no front-end developer, but this is simple even for me, who has no experience whatsoever. So what happens here? First, we connect the client to the node. We have relay node defined in the Fluence.ts file. Let me show you. So relay node is a third node from testnet environment, and the environment comes from Fluence network environment library. You should use testnet environment always, but this index you can switch. You can use several nodes. You can use all of them. I think there are like 10 of them right now. You can use any other, or you can stick with this one. It's the most used node we have. I will show you that also. So we have relay node. We connect there through create client function that we take from Fluence.js SDK. And well, we basically set the client to use it later. It's really obvious. And then we execute curl request. Once this request function is executed on the button, so we have this button, and on click it just executes request function that in its turn executes curl request, which in its turn sends script to the node. And it returns promise, so we wait for it. And finally, we set the data to be displayed here. You can see that we access std_out field. So the data, the structure returned from the Rust, right? So we had this, we had a structure returned from Rust, and it had some fields, and those fields, they are deserialized to JavaScript objects, to JSON objects, and you can access their fields in a simple way. Later, it will all be smoothed out with, it will be all, will all have types, proper types, so you couldn't use wrong field, but currently you have to be careful about that. But I think that's the nature of the JavaScript and TypeScript, that you know that these are dynamically typed languages, so you have to be careful about fields of the structures anyway. Okay, so front-end works. We have our first, we just had our first backend implemented, and we made a front-end app for it, and it can implement these /duckduckgo command of our chat, and you can start right from there. You can start developing your app right from there, and with a few customizations, you can already hit those bounties, the first two. Just be sure to customize your apps to do something different, not copy-paste the existing code. Okay. Any questions so far? Seems like no. I hope there are still people watching me. But anyway, this all will be recorded, so you will be able to watch that on YouTube, I hope, or somewhere. So you will be able to use that video as a hand of help through the workshop. And we have documentation also to assist you, so I'll talk about that. Okay.